This is the first part of lesson 11.2, and we are going to talk about using congruent triangles. Okay, for the warm-up, you are going to first decide which congruence test, if any, can be used to show that the two triangles are congruent. So just as a reminder, we have learned three congruence tests. They are side, 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 angle, side, and remember that one, the angle has to be included between the two sides, and angle, side, angle, and that one, the side has to be included between the two angles. So looking at number one, we see that AD is congruent to DE. We see that AT is congruent to ET. That's only two sides though. So the question is, do we have an angle or do we have a side? Now, one thing you cannot do is you cannot say, well, these two look like they're the same. That's not good enough. What we can say, however, is that DT is the same as itself, and that's actually called the reflexive property. We'll talk about that a little bit more later. But since DT is the same as itself, we could say that triangle ADT is congruent to triangle EDT because of side, side, side. Now remember that it is very important that the order matches, so A goes with E, D goes with D, and T goes with T. You can do that in a different order, so you could say TDA, but then you would have to say TDE, okay? One other important thing to note is that just because these letters are the same, that does not automatically mean that they match each other. We're going to see some examples down the road where even though they have the same letters, they're not corresponding parts, so just be aware of that. Okay, number two, we see that we have angle E and angle R, and we have EF and QR. That's an angle and a side, so I would either need another side, like that, or I would need another angle, like that. However, I don't have either one of those things, so I don't have enough information here to say whether they're congruent or not. They might be congruent, but I cannot prove it. So that's where I would say not enough information. It doesn't matter if they look like it or not. I can't prove it. Okay, number three. We see that AC is congruent to EC. We also see that BC is congruent to DC. Now, right now, we've got these angles marked and that they're congruent, but even if they were not marked, we would know that they're congruent. And the reason that we know that is because they're vertical angles. Okay, so vertical angles are congruent. So what we have is we have a side, an angle, and a side, with a side, angle, and side that matches. So because of side, angle, side, we would say that, and then you have to get the order right. So I like to do my first triangle usually in alphabetical order, so I'm going to say ABC. But then I'm locked into how I have to say the other triangle. So which one goes with A? It's going to be the side that's touching the single marked one, so it's going to be E, and then D, and then C. So just because the first one's in alphabetical order, remember, doesn't mean the second one will be in alphabetical order. Okay, number four. We're going to prove, and we talked a little bit about proving before, but when you prove something, you have to give every single reason why. You can't leave anything without a reason. So we're going to prove whether or not, so it might be true that it's not true, if that makes any sense. It may be true or may not be true, that the two triangles are congruent. And I'm going to tell you I want you to use side, angle, side. Now, the reason I'm telling you to use side, angle, side is just so we can kind of narrow down the path that we're going to take. It doesn't mean that that's the only way that something can be done. I'm just telling you because I have this set up for you, we're going to do this way. Okay, so we're going to start out with these statements right here. We've got these 6 statements, and if you look at what it says ln is equal to what? So look at ln right there. It's equal to 45. Well, I already know that, okay? I didn't have to work for it. I didn't have to solve anything. I didn't have to do any calculations. It was just right there. And mn, same thing. I just know that it's 28. TV is 45. The measure of angle n, because this is 90 degrees, or a right angle there, I know it's 90 degrees. Same with angle V. And then TU is 52. Now, one thing to note is that none of those did I have to work for. I didn't have to do anything. And that's why the reason is given. When we have 2-column proofs, we have these 2 columns, and on the left is our statement, and on the right is our reason why. So why can we make that statement? So the reason why we can say all of these things are because it was given to us. Okay? Given means that you don't have to do anything to get that information. All right, now the next step, so step number 2 right here, UV is equal to, okay, I don't know that one. So you need to think, well, how can I find that one? Now, in these types of proofs where I give you some hints, okay, you can take that hint and go, oh, Pythagorean theorem. So we're going to say 45 squared plus x squared equals 52 squared. So 45 squared is equal to, well, I don't know what it's equal to, but I'm going to put it in my calculator. 45 squared plus x squared. And so when I get all done, I'm going to have x is equal to the square root of 679. That is a decimal. It's an irrational, so I'm not going to bother rounding it or anything. I'm just going to write square root of 679. Okay? And again, the reason that I know that is because of the Pythagorean theorem. Okay, step number 3. It says ln is congruent to. So the segment ln is congruent to, it needs another segment. So what is ln the same thing as? It's the same thing as TV. Angle n is congruent to angle v because they're the same. mn is congruent to, you want to say uv, but is it? Remember that uv, we just found out, is the square root of 679, which if you do that calculation, that is not equal to 28. So actually mn is not congruent to uv. And so because of that, well, the reason why we said these other ones is because congruent parts have equal measures. So if they have the same measurement, they're congruent. But since mn and uv do not have equal measures, they're not congruent. So my conclusion is that triangle LMN is not congruent to triangle TUV. And the reason is because there's no third side congruent. Or you could say that MN is congruent to, or is not congruent to UV. That's basically what threw the whole thing apart. So we're just proving that those two are not congruent. Not that I don't have enough information. I do have enough information. They're not congruent. Okay, the next one, prove whether or not the two triangles are congruent using side, side, side. Now you notice that I don't have any givens here. And that's because the only thing I have given is my picture. In order to find out how long these are, I'm going to have to count, or I'm going to have to use Pythagorean theorem or distance formula. And so in the first statement, FH, I'm going to actually count that. Now, it doesn't say counting right there. It says Pythagorean theorem or distance formula. We could use the distance formula with those two ordered pairs to find the distance. It's just that that would be a lot more work, so we can just count. It's the same thing, actually. Vx is also equal to 4. Now, one thing you have to remember when you're doing this is that when you're doing something like finding HG, okay, first off, you're going to use a triangle to do that. So Pythagorean theorem. So this is 1, this is 5. So you're going to say 5 squared plus 1 squared equals x squared. So that's 25 plus 1, so 26. So this is the square root of 26. The thing you have to remember, though, is that when you go to find xw, just because you want it to be the square root of 26 does not make it so. You have to actually check. You have to actually calculate it. So now that I draw the triangle and I see that those sides are 1 and 5 as well, then I do know that that's equal to the square root of 26 also. But a common mistake that people make is they think, oh, that one was square root of 26, so this one is too, without actually checking. You have to check. Okay, FG. Again, to find FG, I'm going to have to draw in this triangle, use Pythagorean theorem. So that's 3, and this is 5. So I'm going to say 5 squared plus 3 squared. So that's 25 plus 9 is 34. So FG is the square root of 34. Okay, so that's what I've got there. And the reason why was the Pythagorean theorem, or you could have used the distance formula as well. Okay, the next step. And so these proofs that I have, these fill-in-the-blank proofs, it's just kind of like holding your hand through the proof and before you go independent. And we're not actually going to do really any independent ones this year. Vx is congruent to what? So what is that congruent to? And we find out that it's congruent to FH. And XW is congruent to HG. Now people wonder, could I do GH? You can, but when you go to write your congruent statements, if you already have things matched up, it's a little bit easier. So I like to do them in the correct order, even though we're just talking about the segment being congruent. And then VW is congruent to GF. So it's FG. So FG. Okay, and the reason why those are true is because since they have equal measures, they have to be congruent. All right, so because of that, look at what we've shown. We've shown that this side's congruent to that one, this side is congruent to this side, and this side is congruent to this side. So I have shown by side, side, side that this is true. So you can just repeat what it says in the statement up above. Here's what you're trying to prove, so now I've proven it. Okay, in today's lesson, we're going to start out by talking about other congruence tests. So just as a reminder again, last time we did side, 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 angle, side, and angle, side, angle. Also, I told you that there is a reason that side, side, angle does not work. If you want to go to this math open reference and then just instead of AAS do SSA and see what comes up, or you can search for SSA. Don't type the other way because it won't come up with anything. But there's reasons why that won't work. Now, sometimes when you have two triangles and they have two sides and then an angle, they're going to be congruent, but sometimes they're not. And that's why it's not a congruence test, because you can't have a congruence test that sometimes works and sometimes doesn't. These congruence tests always work. Okay, so we're going to talk about two other ways to prove triangles are congruent, so two other tests. And the first side is angle, angle, side. And that's when you have two angles followed by a side that's non-included. Okay, that's different than angle, side, angle. And so that is a test to tell whether two triangles are congruent is by angle, angle, side. In this math open reference, and these are links that I have on Canvas, but this one right here, if you type that in, it's got a little thing where you can drag points to see how if you have two angles the same followed by a side, how the two triangles have to be the same. And then same thing for the side, side angle. You can see why it's not true. Okay, the other one, the last congruence test is called hypotenuse leg. Now remember that the word hypotenuse is only good for a right triangle. No other triangle has a hypotenuse. So the hypotenuse leg theorem, or HL theorem, is only good if you have a right triangle. And so that makes it unique. And if you look at the picture, you've got this right angle, and then you've got two sides. Well, we already just said that side, side, angle, or angle, side, side is not a test, but it does work when you have a right triangle. Now, because it doesn't work all the time, we can't say angle, side, side, or side, side, angle. So because it always works in a right triangle, we call it hypotenuse leg, because that means it's a right triangle because of hypotenuse. Okay, so we have a total of 5 congruence tests. There's side, 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 angle, side, side, angle. By the way, those are postulates, which means that they can't be proven. They're just a basic foundational piece. But the next one, the angle, angle, side, that's a theorem and that can be proven. Now these 4 tests, they work for all triangles. Okay, they always work. The hypotenuse leg theorem, that can also be proven, but it only works for right triangles. So we're not really going to use that one very much, but I wanted you to make sure that you knew that that was a test. Okay, a couple of definition words. So first off, the word proof. When we talk about proving something, it's like if you're in a court of law and you're trying to prove that somebody's guilty, you can't just say, well, they look guilty, so therefore they are. You have to actually give evidence to that. You have to convince. Okay, so you have to have reasons for everything. In math, we usually start out with 2-column proofs because it's organized, and we have the label statements and reasons, and it just helps us be neat and efficient about our proof. Okay, there are some properties that are really common when we do proofs, and number 1 is the reflexive property. And that's like if you look back at that first question that we did, where we said dt is congruent to itself, that's a reflexive property. And so it seems like an obvious statement, but again, we have to have a reason for everything. So if we're going to say dt is congruent to dt, the reason is reflexive property. Second, a really common one is substitution property. It's also a postulate or a property, which means basically you can't prove it, it just is. But it says if A is equal to B and B is equal to C, then A and C have to be equal also. And we use that all the time. So if we say x plus 12 equals 10, and so we find out that x is equal to -2, that means I can substitute this in place of x and have it be a true statement. So substitution of property is something that's very familiar to us. And number 3, we kind of talked about this in the previous 2 problems, but congruent parts have equal measures. That means if 2 pieces have the same measurement, so like if this angle is 20 degrees and this angle is 20 degrees, then they are congruent angles because they have equal measures. Okay, so we're going to do this one proof and then I'll switch to another video. But in this proof, we're going to prove whether or not these two triangles are congruent. And I'm going to tell you, let's use angle, angle, side. Now again, that's not saying that that is the only way. It might be the only way, but this is the way we're going to do it just because I have this proof set up, and if you try to do something else, it's not going to work, okay? So on the left, we have our statements. On the right, we have to put the reasons. I don't have any of the reasons there, so we have to figure out what they are. So start out with this measure of angle E equals. Well, that's easy. Did you have to work for that? Did you have to calculate anything? Did you have to set up an equation that you had to solve? No. The reason you knew that is because it was given to you. It's in the picture, all right? So all of these things that we know, they're known because it was given to us, and so that's the reason. Usually we start off proofs with given statements, and usually I like to put all the givens together, but sometimes they might be split up depending on how we're going to use them. Okay, the second statement, the measure of angle G is equal to, all right, what is that one? So how do you figure that out? We know that 180 take away 105 take away 31 is going to equal angle G, and I know that because all of the angles in a triangle equal 180. So do that calculation, the 180 minus 105 minus 31, and we're going to get 44 degrees. Now what's the reason why I knew that? I knew that because the sum of the angles in a triangle is 180 degrees. Now you do need to write this out. You can abbreviate some words, like I've got, angles and triangle, but you have to write out what your reason is. It has to be understandable. So you can't just say sum is 180 or 180. You have to say what you mean. Okay, for angle J, I'm going to do the exact same thing. I'm going to do 180 minus 105 minus 44. And when I'm done, I'll get 31. And that falls under the same reason, which is why I have them grouped together. Okay, the third one, EG is equal to, let me erase the things I've already got here. So EG, so you look at your picture, EG, it's 10.3. I don't have to try for any, I don't have to do anything. It's just there. HJ, same thing. So those would fall into a given category. I didn't have to do anything for that. Okay, the next one, it says angle E is congruent to. So which angle is it congruent to? It's actually congruent to angle J. Angle F is congruent to angle I. Side EG is congruent to HJ. Why are they congruent? They're congruent because they had equal measures. So we're going to write congruent parts have equal measures. And that's the reason why. Now, because of that, you'll notice that I have an angle, and I have a side. So I'm ready to make my final statement. My final statement is to say what it was I was trying to prove. So triangle EFG is congruent to triangle JIH, and the reason is because of angle, side. Writing that down right there is really helpful so you can see, make sure you've got everything and you see what order you have it in so you say the right statement. We're going to continue this lesson now in part 2.